Hello everyone, a very good evening to all. Myself, Vivekananda Naik, I am PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So, today I welcome you all once again for this 7th interaction session on the NPTEL Course Experimental Physics 1, which is being float this July 2025 session with course code NOC 25 PH51. So, today we will solve a few problems that will be based on week 7 course content or lectures of the course. So in this week, so if you talk about the week 7 contents, so there was a theory and experiment regarding the viscosity of fluid, theory, experiment, and data analysis regarding viscosity of a fluid, and then experiments related to oscillations like Pohl's pendulum, and coupled pendulum. So let's discuss a few things briefly about viscosity of a fluid. So viscosity of a fluid is a measure of the fluid's resistance to flow. So it is so mathematically there is a physical quantity that represents the viscosity of a fluid, which is called as coefficient of viscosity, that is eta, and it is defined as the ratio of viscous force per unit area and velocity gradient. So we know whenever there is a flow of a liquid through a tube, so the velocity at the center of the tube is maximum, and the velocity, because fluid flows in different layers, so the layer present at the middle of the center of the flow has maximum velocity, and the velocity starts decreasing as we move toward the center. So this is the profile of the velocity. A maximum is at the center, minimum is at the periphery. So there is a velocity gradient. So that velocity gradient is defined by the velocity gradient is defined as dv by dr. So the coefficient viscosity is viscous force per unit area. So F is viscous force and A is the area of cross section. So viscous force for unit area is F by A, and the velocity gradient is dv by dr. And the units of viscosities are poise and decapoise. So 1 decapoise is 10 to the 1 decapoise is 10 poise, and viscosity is a property of a liquid and it doesn't change if the amount of matter changes. So viscosity is an intrinsic property. It doesn't depend upon the mass of the substance. For example, density. Density is also an intrinsic property of a substance. So viscosity is an intrinsic property of the liquid. And if we talk about oscillations, so oscillation is defined as the process of repeating variations of any quantity about its equilibrium value, or the measure of its equilibrium value in time. So there are different types of oscillations. So free oscillation, damped oscillation, forced oscillation. So if you talk about different types of oscillation, what is free oscillation? So when a body vibrates with its own frequency, it is called as free oscillation. The free oscillation has a constant amplitude and period without any external force to set the oscillation. So if we talk about free oscillation, the amplitude and the time period of motion, it remains fixed. For example, vibrations in a tuning fork. And if you talk about damped oscillation, so most free oscillations, so in case of free oscillations, what should happen? The amplitude should remain the same and the time period of oscillation should remain the same, but most of the free oscillations they eventually die out due to ever present damping forces in us. For example, if you oscillate a pendulum, there is air drag or force of there is opposing force from the air, because air has some density, so that also helps in reducing the amplitude and the motion, the oscillation then is called as damped oscillation. So that result in damping, the amplitude of oscillation reduces with time, and this results in increasing energy loss of the system. For example, decaying oscillation of a pendulum. So when you start oscillating a pendulum, with time its amplitude as well as its time period, that so if for a particular time period its amplitude decreases gradually and there is energy loss from the system. And if you talk about force oscillation, so when one oscillation, so in case of free oscillation there is no external force, and in case of damped oscillation is a type of forced oscillation, but in this case the force is in opposite direction, that's why the amplitude decreases. And here when something oscillates by being influenced by an external periodic force, it's called as force oscillation. The amplitude of oscillation experiences damping but remains constant due to the other external energy supplied to it. For example, when you play with a toy that involves an object being supported by an elastic band suspended to your finger, in the beginning, if you hold the finger still, the object bounces up and down with a small amount of damping. If you move your finger up and down, the object will follow along. So we will discuss it. We will discuss this example in more details in upcoming time. So let's talk about a few equations related to free oscillation. So in case of free oscillation, the this is the expression, the position which is a function of time, it is a sin omega t, and the acceleration it is minus a omega square sin omega t. So you can say it a t equals to minus a sin omega t omega square. So it is minus omega square x. So a is direct proportional to x. The acceleration is direct proportional to the distance or displacement. So this is this is the example. So it is varies periodically. So this time period. So suppose what is the time period? The time period is from one maximum to another maximum. So this is the overall time period. What is the amplitude? The maximum value of the quantity. This is amplitude. So this is a. This is time period. So if you talk about Newton's second law of motion, mass into acceleration force, this force is given by minus kx. So if you solve this equation, it will come out to be like this. A is nothing but x double dot. So x double dot plus omega 0 square equals to x. However, in case of damped oscillation, there is an additional term where this gamma is present. So this gamma is p by m, which is called as damping constant, and it has dimension of frequency, and p is called as coefficient of damping force. And if you solve it, the position will come out to be x0 e to the power minus gamma t by 2 cos omega t plus 5, where this is the damping term. So there are different types of damped oscillation. One is under damped, over damped, and critically damped. So there are different type of oscillation. So one is over damping, so it falls up rapidly. Then two is critical damping, and three is under damping. So like you see, the time period remains the same. So here this is the time period. Time period is same, but the amplitude goes on decreasing. So this is the amplitude in first case, and here the amplitude goes on decreasing. So this is suppose a. This is a1. This is a2. So as the time moves, the amplitude goes on. Now if you talk about force oscillation, so we know this is the form of force oscillation. Then this is the equation f0 sin omega t j terms, and the amplitude is given by f0 divided by m square omega square minus omega 0 square plus b square omega square. This is small damping, medium damping, and heavy damping. So now if you take out this is the example that we are talking about. So when we move it constantly, so these were two way. Now the depends upon the frequency of the force, and it determines the amplitude of the oscillation. So this is a damped oscillation when A gradually goes on decreasing, and this is the condition of resonance due to which the energy constantly increases and the amplitude increases continuously. And this is a natural oscillation where A is constant. So resonance, there is a condition, for example, there is a phenomena which is called as electron cyclone resonance. So in that electron cyclone resonance, what happens? So when the frequency of oscillation, for example, the cyclotron frequency of an electron in a magnetic field, when it matches with the frequency that we are injecting into the system, then those two frequency, if they match with each other, then there is resonance. So when the frequency of the oscillation is equal to the frequency of the electromagnetic wave, then the electric field of the electromagnetic wave will be seen as a constant for the electron, because the same way the electron is also oscillating, so it constantly gained energy and it gets accelerated. So that's why the amplitude goes on increasing. Electron cyclotron resonance is here. So now let's discuss about simple pendulum. So we know this is a simple pendulum. There's a massless string, and this is the mass of the pendulum. So if you solve it by balancing the force and all, then you will say, then you can find the time period of oscillation. So L is the length, G is acceleration due to gravity, and T is time period of oscillation. So in case of compound pendulum, so here this is the compound pendulum. There is a center of mass somewhere. So this is called a center of mass, and the time period of oscillation is defined by T is equal to 2 pi I divided by mgd, where I is the what is I? I is moment of inertia. Now experiment that was covered in the week's content, coupled pendulum and poles pendulum. So poles pendulum is a forced oscillation. Coupled pendulum, so coupled pendulum, this is coupled pendulum. Two pendulum is coupled with the help of a spring. So there will be theta 1 and theta 2 depending upon the spring. So that it has two frequency. One is when they are moving along same direction, another they are moving in opposite direction. So this is G by L, another frequency is G by L plus 2K by M, where K is the spring constant. And this is an example of pole pendulum. The pole's wheel or rotating torsional pendulum allows the investigation of forced harmonic rotary oscillation. The oscillation system is connected to an excitation linkage which is driven by an adjustable speed DC motor, so that the restoring springs periodically extends and compress. So we are applying force in between with a particular frequency, and this results in the force oscillation, and this pole pendulum is an example, and the experiment was covered in the week's content. So now let's solve a few problems based on the concept of the week 7 lectures. So here the first question says the time displacement that is t. So t is along this direction, so this is time, this is displacement. So the time displacement relation for the motion of four particles are shown in figure 1, figure 2, figure 3, figure 4. And the question says which figure or figures may be considered as periodic motion. Options are option A, figure 1 and figure 2, option B, figure 2 and figure 3, option C, figure 2 and figure 4, or option D, figure 1 and figure 4. So there are four figures, and each figure shows the variation of displacement with respect to time, and from these figures we need to find out which of these are periodic motions of a particle. So I'll give you a few minutes to try this question and solve it, and then we will discuss this in based on the concept which two figures will be called as periodic motion. So, uh, so the question was the time displacement relations for the motion of four particles are shown in the figure, and we need to find out which is called as a periodic motion. So, what is the definition of periodic motion? So, the in case of the periodic motion, the regular interval of time, the motion should get repeated. For example, the amplitude as well as the time period, that should remain same, and it should be a periodic motion. So here, if you see in figure 1, the motion is not being repeated. In figure 2, this motion is repeated because the time period and amplitude, so this part is again getting repeated. So this is a periodic motion. Here the particle is coming to 0, but the amplitudes are not same. And also, if you see, the time period is fixed, but the motions are not getting repeated. The amplitude is changing with time, but they are not in periodic change. So this is not a periodic motion, and this is another example of periodic motion where the time period and amplitude, they are getting repeated. So figure 2 and figure 2 and figure 4. So option C is the correct option. Now question number 2. Question number 2 says sin omega t minus cos omega t represents a, option A, simple harmonic motion with amplitude root 2, option B, not a simple harmonic motion, option C, simple harmonic motion with frequency 2 omega, and option D, simple harmonic motion with amplitude 1. So we know for simple harmonic motion the formula is x is equal to a sin omega t, or if you calculate, we can calculate v, which is dx by dt, and we can calculate a, which is d square x by dt square. So it will be proportional to x, but it will not be proportional to x. So we need to find out if sin omega t and cos omega t is present, then uh, what should be its nature. So whether it is a simple harmonic motion, if it is simple harmonic motion, then what is its amplitude, what is its frequency, what is its amplitude. So there are four options. So I'll give you a few minutes to calculate it and decide which is the correct answer, and then we will discuss. So this is the expression. So this is x equals to sine omega t minus cos omega t. So now let's break sine omega t minus cos omega t into a form from which we can decide whether it is a simple harmonic motion or not. So we can take root 2 common, then it's 1 by root 2 sine omega t minus 1 by root 2 cos omega t. So if you take root 2 as common, then root 2 is sine pi by 4 is root 2, so it is sine omega t into cos pi by 4 minus sine pi by 4 into cos omega t. So it is root 2. This is sine a into cos b plus minus cos a into sine b. So this is sine a minus b. So this is sine omega t minus pi by 4. So x is root 2 sine omega t minus pi by 4. So if you compare it, we have x is equals to a sine omega t, x is equal to root 2 sine omega t minus pi by 4. So if you compare, so here amplitude is root 2, so it represents a simple harmonic motion with amplitude root 2. So it represents a simple harmonic motion with amplitude root 2. So the correct answer will be option A, simple harmonic motion with amplitude root 2. Now we move to question number 3. Question number 3 says, which of the following relationships between the acceleration a and the displacement x of a particle represents simple harmonic motion? Options are option A equal to 2x, option B a equal to minus 10x square, option C a equals to 10 root x, and option D a equals to minus 0.5x. So here a is acceleration and x is displacement, and from this relation we need to find out which is a simple harmonic motion, which expression simple harmonic motion. So first we need to find what is the condition for simple harmonic motion, and then we will find whether this is a simple harmonic motion or not. So I'll let you a few minutes to solve this question and then we will discuss. So we know what is the form of a simple harmonic oscillation. It is x equals to a sine omega t. So what is dx by dt? It is a omega cos omega t, and d square x by dt square is equals to minus a omega square sine omega t. So minus omega square a sine omega t. This is nothing but x. So a is minus omega square x. This is a simple harmonic motion. So in case of simple harmonic motion, a is right proportional to x but with negative sign. So if you see the options, option a equals to 2x. So in this option, a is right proportional to x but negative is not present. Option B, a equals to minus 10x square. Here a is right proportional to x square, so again it is not possible. Option C, a equals to 10 root x. Here a is proportional to root x, so here it is not possible. And option D, a equals to minus 0.5x. This is option. So option A here, sorry, a right proportional to x and also negative is present. So option D is the correct answer. So here a is right proportional to x and negative sign is present. I hope this is clear to everyone. Now we'll move to question number 4. Question number 4 says the motion of a particle executing simple harmonic motion is described by the displacement function xt equals to a cos omega t plus phi. If the initial position of the particle is 2 centimeter and its initial velocity is omega in centimeter per second, what is its amplitude? So options are option A 1 centimeter, option B 2 centimeter, option C root 3 and option D root 5. So the motion of particle is given and the displacement, time dependent displacement has the form A cos omega t plus phi. So here the question, according to question, at t equal to 0, x is 2 centimeter and its velocity is omega. But we need to find out what is the amplitude. So I hope this is clear to everyone. So I'll give you a few minutes to calculate this question and then we will discuss. So let's solve this one. So the expression for displacement is given as xt is equals to a cos omega t plus phi. So, and in the question it is given t at t equals to 0, x is 2 centimeter. So 2 equals to a cos phi. This is one equation. Now from this we can get dx by dt, which is a omega, sorry, minus a omega sine omega t plus phi. So here also it was given at t equals to 0, v equals to omega. So omega equals to minus a omega sine phi, or a sine phi. So omega gets cancelled, is equal to minus 1. This is 2. Now this is a cos phi equal to 2, a sin phi equal to minus 1. So 1 square plus 2 square, what it will give you? It will give you a square cos square phi plus a square sin square phi equals to 4 plus 1, 5. So we know sin square phi plus cos square phi equal to 1. So if you take a square as common, it will be a square equals to 5. That implies a is root 5. So the amplitude of simple harmonic motion is root 5 centimeter. This is the answer. So the correct option is option D. So here x equals to a cos omega t plus phi was given to us. Then there was a condition that at t equal to 0, particle position is 2 centimeter, and at t equal to 0, particle velocity is omega. So from these two conditions we got two equations. So when we add the two equations and when we take square of the two equations and add it, then we found out the a square is equals to 5. So a is root 5. So I hope this is clear to everyone. Now we move to question number 5. Question number 5 says the acceleration due to gravity on the surface of moon is 1.7 meter per second square. What is the time period of a simple pendulum on the surface of moon if its time period on the surface of earth is 2 seconds? So g on the surface of earth is 9.8 meter per second square. So g on the surface of moon is 1.7 meter per second square. G on surface of earth is 9.8 meter per second square. So when for a pendulum, for a simple pendulum, on earth time period is 2 seconds, then on moon what will be the time period? So these are the options. Option A 1 second, option B 2.4 second, option C 9.8 second, and option D 4.8 second. So I'll give you a few minutes to try this question, and then we will discuss what will be the correct one. So we know. So here the problem is given for a simple pendulum, and for a simple pendulum we know for a simple pendulum the time period for oscillation is given by 2 pi L by G root over, where T is the time period of oscillation and G is acceleration due to gravity. So the time period of oscillation is inversely proportional to root G. So the time period of oscillation on moon divided by time period of oscillation on earth will be root of G earth by root of G moon, isn't it? So T moon will be root over of G earth by G moon into T earth. So T earth is 2 into, on earth the moment the acceleration due to gravity is 9.8, and on moon it is 1.7 root over. So what is the root over of 1.9.8 by 1.7? It is 2.4, 2 into 2.4. So it is 2 into 2.4, which is 4.8 second. So the correct answer is option D, 4.8 seconds. So when the acceleration due to gravity is decreased, so the time period of oscillation increases. And the correct answer is 4.8 seconds that we calculated from this relation. If this is clear to everyone, now we move to question number 6. Question number 6 says a body describes simple harmonic motion with an amplitude of 4 centimeter and a period of 4 seconds. Find the acceleration A and velocity V of the body when the displacement is 4 centimeter. So a body describes simple harmonic motion with amplitude of 4 seconds and a period of 4 seconds. Find the acceleration and velocity of the body when the displacement is 4 centimeter. So simple harmonic motion of a body is given, amplitude is 4 centimeter and time period is 4 seconds. Find the acceleration and velocity of the body when displacement is 4 centimeter. So when x is 4 centimeter, then what is A and V, that we need to find. So these are the options. Option A equals to 0, V equals to 0. Option B, A equals to minus pi square, V equals to 0. Option C, A equals to minus pi, V equals to 5 centimeter per second. Option D, A equals to minus 10, V equals to 10 centimeter per second. So I'll give you a few minutes to solve it and then we will discuss. So let's calculate the velocity and acceleration. So you know x is a sin omega t. So a is 4 centimeter and t is 4 second. Now what is b? B is a omega sin, sorry, so b is a omega cos omega t. A is equals to minus omega square x. If you compare it with the time period equation, so t is equals to 2 pi L by G root over, that implies t square equals to 4 pi square L by G, or G equals to 4 pi square by t square into L, and here it is negative, so A will be minus 4 pi square by t square into 4, that implies minus 4 pi square by t square. T is 4 second, so 4 square into 4, so minus pi square. Now what is b? B is plus minus a square minus y square root over, so plus minus a. So here the question says find the acceleration velocity when the displacement is 4 centimeter. So the displacement, suppose a square minus x square, this is, because if you solve this equation, v square equals to a square omega square cos omega t, so from there you can get. So let me solve it. So we got x equals to a sin omega t, b equal to a omega cos omega t, b equal to a omega cos omega t, which is plus minus a square is 4 square minus 4 square root over, so 0. So the correct answer is option B, equals to minus pi square meter centimeter per second square, and B is 0. So we move to the next question. The question says two capillary tubes of the same length L but different radius R1 and R2 are fitted in parallel to the bottom of a vessel. The pressure head is P for both of the tubes. what should be the radius of a single tube of length L that can replace the two tubes so that the rate of flow is same as before. So options are option A, R equals to R1 plus R2, option B, R equals to R1 R2 divided by R1 plus R2, option C, R equals to R1 square plus R2 square, and option D, R equals to R1 to the power 4 plus R2 to the power 4 to the power 1 by 4. So here are the four options. So two capillary tubes of same length L but different radius is fitted parallel to the bottom of a vessel. Suppose this is a vessel and so this is of ready 1, this is of ready R1, this is of ready 1 2. So the length for both is same. This is L, this is L. What should be the radius of a single tube of length L that can replace the two tubes so that the flow rate is same as before? So if you want to replace this to a single tube and flow rate should remain same, flow rate same, then what should be the value of R? Options are option A, R equals to R1 plus R2, option B, R equals to R1 R2 divided by R1 plus R2, option C, R equals to R1 square plus R2 square, and option D, R equals to R1 to the power 4 plus R2 to the power 4 power 1 by 4. So I'll give a few minutes and then we will discuss. So the total volume of liquid that is flowing. So volume of liquid. So V is V1 plus V2. We know V is P pi divided by 8 eta L R1 to the power 4 plus R2 to the power 4. Now, if we make a tube of R radius and a single tube we will connect, then what happens? So V will be P pi divided by 8 eta L R to the power 4. So that implies, so this is equation 2, this is equation 1. That implies R to the power 4 is equals to R1 to the power 4 plus R2 to the power 4. So R will be R1 to the power 4 plus R2 to the power 4 to the power 1 by 4. So when two tubes is replaced by one tube, this is radius R1 R2 and this is radius R, then R will be R1 to the power 4 plus R2 to the power 4 by 1 by 4. So the correct answer is option D. Now we move to question number 8. Question number 8 says, consider the damped simple harmonic motion is given by y equals to a e to the power minus bt sine omega t. Here e to the power minus bt is damping factor. Its amplitude reduces to 1 by 5th of its amplitude at t equal to 0 after 5 oscillations. After 10 oscillations, its amplitude will be option A 1 by 10, option B 1 by 20, option C 1 by 25, and option D 1 by 100, A by 100. So this is a damped simple harmonic oscillation, simple harmonic motion. So its amplitude will go on decreasing with each time period. So here the amplitude reduces to 1 by 5th at t equals to 0 after 5 oscillations. Then after 10 oscillations, what will be the amplitude? So I'll give you a few minutes and then we will discuss what will be the correct answer. So y is given as a e to the power minus bt sine omega t. So at t equals to 0, y equals to a, because e to the power 0 is 1 and sine 0 is sorry, so y is a into 0 0, but so amplitude is given as amplitude is at t equals to 0, amplitude, suppose this is k, is a e to the power minus bt a e to the power 0, that is a. So after 5 oscillations, what will be amplitude? Suppose a5 will be a e to the power minus b 5t, and it is given the question that it is 1 by 5th of the amplitude. So this is a by 5. So that implies e to the power minus 5 bt equals to 1 by 5. Now after 10 oscillations, what will be a10? A10 equals to a e to the power minus 10 bt, that implies a e to the power minus 5 bt square. So a into e to the power minus 5 bt, we found it as 1 by 5 here. It is a by 25. So after 10 oscillation, the amplitude would be reduced to 1 by 25th. So the correct option is option C. I hope this is clear to everyone. Now we'll move to question number 9. So question number 9 says spherical balls of radius r are falling in a viscous fluid of viscosity eta with a velocity v. The retarding viscous force acting on the spherical ball is option A inversely proportional to r but directly proportional to v. Option B directly proportional to both radius r and v. Option C inversely proportional to both radius r and v. And option D directly proportional to radius r but inversely proportional to v. So I'll give you a few minutes to think about this question and decide which one is the correct one answer, and then we will discuss about the concept of viscosity and we will find out what is the correct dependence. So we know the viscous drag is given by the force and the expression is, so viscous force F is given by 6 pi eta r v. So F is directly proportional to r, directly proportional to eta, and directly proportional to v. So it is directly proportional to both the radius and velocity of the spherical ball. So this was a bit straightforward. Now we move to the question number 10, the last question of today's interaction session. Question says, two capillaries of same length and radii in the ratios 1:2 are connected in series. A liquid flows through them in streamlined condition. If the pressure across the two extreme ends of the combination is 1 meter of water, the pressure difference across fast capillary is option A 3.4 m, option B 4.9 m, option C 0.49 m, and option D 0.94 m. So the question says, so there are two capillaries of same length and radii 1:2. So one capillary is this and another is this. So this is R and this is 2R. So radius are in the ratio of 1:2. Now the question says the pressure across the two extreme end is 1. So the after the combination, the pressure across the two extreme end is 1 meter and for a streamlined condition. And what will be the pressure difference across the fast capillary? So from here to here, what will be the difference? So let the pressure difference between the, so let's the pressure difference between, suppose this is the tube, suppose this is P1, this is P, this is P2. So pressure difference from fast tube, so pressure difference across the fast tube is P1 minus P, second tube is P minus P2. So this is radius R, this is radius 2R. So in streamline flow, V is P pi r to the power 4 divided by 8 eta L. So for fast tube, it is V is P1 minus P pi r to the power 4 divided by 8 eta L. This is 1, and for second tube, V equals to P minus P2 pi So this is V. Then similarly P minus P2 pi 2r to the power 4 by 8 eta L. So what will be P1 minus P? So P1 minus P will be V8 eta L divided by pi r to the power 4, and P minus P2 is V8 eta L divided by 16 pi r to the power 4, because R2 is 2R1. So if you add 3 plus 4, it will be P1 minus P2 is equals to 8 eta LV divided by pi r to the power 4 1 plus 1 by 16. It is 17 by 16, 8 pi eta V divided by r to the power 4. So it is given, this P1 P2 is given 1 meter. So 1 equals to 17 by 16, 8 eta LV divided by pi r to the power 4. So let me add another slide. So that implies what is V? So V is 16 pi r to the power 4 divided by 17 into 8 eta L. So this is IV. So from 3I and V, from 3I and V, so this is V. So what we will get? P1 minus P pi r to the power 4 divided by 8 eta L equals to 16 by 17 pi r to the power 4 divided by 8 eta L. So now this pi r to the power 4, pi r to the power get cancelled, 8 eta L get cancelled. So P1 minus P is 16 by 17, 0.94 meter. The correct answer is 0.94 meter, that is option D. So first we calculated the total pressure difference, then we calculated the volume, and from that we calculated the difference between the first tube, that is 0.49 meter. So I hope this is clear to everyone. With this we come to the end of today's interaction session. So in the next session we will be solving a few problems that will be based on the week 8 contents. I hope this solution of these problems will help you in solving your assignments as well as for your exams. With this, I come to the end. That's it for today. Thank you.